Welcome to today's webinar, Safety Products and Electric and Autonomous Vehicle Standards, sponsored by Omnex. I'm Dirk Ducharme, Editor-in-Chief for Quality Digest and your host for today's webinar. Product development in autonomous vehicles, or AVs, will need to incorporate IATF 16949 and risk prevention techniques that have already long been used by the automotive industry. However, IATF 16949 and the Core Tools handbooks will need to change to accommodate the system architecture of system, subsystem, hardware, and software required in safety, EV, electric vehicle, and AV products, and the requirements flow down between customer, supplier, and sub-suppliers. New standards such as ISO 26262, functional safety, and cybersecurity standards, and automotive SPICE will slowly and then suddenly become much more important. And that is part of what we're going to talk about today. Before I introduce today's presenter, just a reminder that at any time you can send questions to us using the Q&A box. You can find the Q&A box in the lower right corner of your screen, or if you see a pull-down menu at the top, just click that and you will see a Q&A button, and you can click that to open up that Q&A box. Send us your questions as you think of them. A recording of this webinar as well as a copy of the slides will be available. You'll be contacted by Omnex on how to receive those materials, so keep an eye open on your email for that information. Okay, today's presenter is Chad Kymal. We're always glad to have Chad here with us. Very knowledgeable. He's a CTO and founder of Omnex Incorporated. Over the course of his career, Chad has served on the Malcolm Baldrige Board of Examiners and has received numerous quality achievement awards, including the Quality Professional of the Year award by the ASQ, the American Society for Quality, their automotive division. He got that in 2005. Chad both developed and teaches auditor training for ISO 9001, IATF 16949, ISO 14001, and OSAS 18001, ISO 45001, as well as an Integrated Management Systems Lead Auditor Training course. Okay, Chad, take it away.
Dirk, thank you very much. Always a pleasure working with Quality Digest. Welcome, everyone. You know, Dirk mentioned a number of standards as he was introducing me. Really, today, what I'm doing, meaning these days, what I'm doing is really a lot of work in these standards that we're about to talk about. And as I'm immersed in these standards, I am assessing, auditing, implementing with Omnex these standards. I can't help but notice all these different issues in terms of what people have done and how things have changed. I actually captured that in a white paper I wrote for Quality Digest. I've done a second revision to it, added about 4 or 5 pages based on comments from readers. And contact Omnex, you know, and we'll send you the second revision of that white paper. The white paper focuses more on design. If some of you saw that paper and came in thinking I'm going to talk exactly about that, don't be disappointed. I'm going to talk to you about what you should know first, and then, you know, keep in touch. I'll do that webinar, a webinar just on how product design needs to change. All right, so let's get started here. Just a little bit about Omnex. We are a 33-year-old company headquartered in Ann Arbor, Michigan. You know, a couple of things that really made us who we are. We did a global rollout of QoS for Ford Motor Company, and we helped write the current QoS that Ford Motor Company is using, but we did that in 1993. Then the 1995-1997 timeframe, we helped them with the emerging market strategy and really helped them around the globe. I won't take up too much of your time. We did a lot of work in the semiconductor industry with the Semiconductor Alliance Council, Assembly Council, sorry about that, and currently doing a lot of work in the aerospace industry also. Here it is, a very global organization. we're very proud that we can service large tier ones, one of the largest tier ones. We help them around the globe in their 300 U.S. plants and 300 European, but also we help them in China, India, etc. All right, so let's get right down to the topic at hand: safety products, electric vehicles, and autonomous vehicle standards. So before we get right into the standards, I'd like to first talk to you about what's going on in the world. What has brought about the shift in product in the automotive industry? And if you don't know about it, let me mention that to you a little bit later. I'll hold that as a key learning for you. Then we'll touch on this autonomous vehicle and electric vehicle basics. And then we'll look at what Omnex calls the 7 pillars, which is the future of in terms of standards, how companies are going to change, and the competencies all of us listeners have to have. As I tell the Omnex trainer and implementer, I said, you have to change. You have to bring in these new competencies, or, we're going to be in trouble looking for jobs. All right. So electric vehicle and autonomous car global movement. What has precipitated this change really is countries, announcing their plans for, phasing out diesel and gas vehicles. This is not the entire list, but you can see here that, looking at, the carbon and carbon footprints and the in terms of reducing the footprints, countries want to phase out gasoline and diesel cars and bring in electric vehicles. Well, if that's all there was, it would be fine. But here's news from the 2 largest car makers in the world, where GM has announced it's going to go all electric, and they will give up, as they say, ditch gas and diesel powered cars. We hear that from Volvo, we heard that from Porsche, we heard that from Volkswagen. So the 2 largest, GM and Volkswagen, say the next generation of combustion cars will be its last. And by the way, it is not just VW. Here is sort of the announcement from a spectrum of OEMs across the board, from BMW all the way to Volvo at the bottom. And what is everybody seeing? Everybody is seeing that customers in the future will be going electric vehicles. And by the way, where are we at? Yes, GM has a few, 2 electric vehicles, but they're planning on bringing out 20 new electric vehicle models by 2023. And they're trying to conserve their cash because they're going to have to put all this money into where they see the market is going. What then about autonomous? Well, let's hold off on that, but let's keep that in mind. What is going on in autonomous cars? So before we go there, what's been happening in the automotive industry currently and the last, let's say, 10 years is that mechatronic systems, electronics and electrical functionality has been added and a lot of safety functionality has been brought in, leading to this announcement in 2016 between the U.S. Department of Transportation and 20 automakers that they'll bring in, AEB, automatic emergency braking. backup cameras so that, cars don't injure children or seniors. In fact, I have a slide a little bit later looking at the path to autonomous cars. The path to autonomous cars actually starts with this incorporation of electronics and safety product, functionality into the car. So keep that in mind as I move forward. So, of course, going hand in hand with that, with this idea of bringing in technology, is the big shift from 2020, where the electronics and software is, let's say, 35% or 33%, all the way to where it hits 50% by 2030. And that's a whole bunch of, billions of dollars that'll get added to electronics and software sectors of the market. So if you're still designing mechanical products, that part of the market is going to shrink, where, you're still going to need some mechanical product for electric vehicles and autonomous, but more than ever, we need to bring in the hardware and software design into our organizations. What else? Those of you listening, if you have been, we have been all brought up in mechanical systems, we need to make a shift into understanding how software works and hardware works. I don't know if I'll get a chance to say this. Well, let me see here. I do get a chance to talk about software. I'll say it then. So as you might imagine, the warranty recalls in software have gone up. In fact, recently I worked with one of the truck OEMs who told me they're seeing 50% of their recall and warranty being software as a root cause. That's why we said in the paper 15 to 50%. So we're not doing such a good job incorporating hardware and software, and especially software. So I'll say it now. It has been my experience, since the mid-2000s, in the companies that I work with, I may or may not have told you, Omnex played a big part in a ISO TS 16949 version for the semiconductor supplement. And because of our involvement with SAC, we did a lot of work in semiconductors and high tech. And, I noticed groups of software people often excluded from audits. And then we would audit them and find out they had no quality management system. Of course, that's changed since 2006. And so software now, the software part of the organization and the hardware part of our organizations are growing in leaps and bounds, especially software. I'll tell you about software and autonomous cars in a little while. But let me just say that this growth in software, we're still treating software, as a stepchild outside the realm of how we do new product development. So there's a long way for us to go in terms of, integrating in software, hardware, and systems. All right. What can we say? That there is an evolution from electric to autonomous. Forget exactly which article I talked about, who are the leaders right now in going towards autonomous. Of course, Tesla gets a lot of press, and so is General Motors' Super Cruise. It's doing wonderfully well in the highways, but they're doing it on a gasoline engine, and of course they're going to have to move that to the electric vehicle. We're all going to go autonomous on electric vehicles in the future. So there will be a shift from electric to autonomous. Once we hit level 4 and level 5, there will be a shift from, there will be what is called mobility as a service, which is the Ubers and the Lyfts will gain importance because there's a thought, not just a thought, it's been there for a while, that there will be a shift from people buying cars to people, using cars as needed. But the idea is, cars are available for 24 hours. Typically, most of us who use it daily use it for 1 or 2 hours at the most. So the idea of using the car the other 22 hours, and that all of us, when the cars completely go autonomous, will call a car to our doorstep, take a trip, and then, it'll go wait for somebody else to use it. So that market is called mobility as a service, and you can see it's projected to be $1.5 trillion by 2030. By the way, there's an increase in revenue. So when you do, the market is not going down, the market is growing overall for the vehicle market. All right. What does this all lead to? And we'll ask the question, why? Okay, let me just point out the alliances. Ford and Volkswagen, by the way, many of these are also falling apart as we speak, but the whole idea of alliances are very important. We'll ask the question, why? You can see that, Argo AI is, one of the startups that has been purchased by an OEM. Daimler, BMW. Suddenly we have these new car companies like Apple, and later you'll see Google. You'll see OEMs, and then you'll see Delphi. OEMs, and you'll see Aptiv. There's Waymo from Google. Toyota investing in Uber. Aurora and Fiat, and so on. So what's going on? Bottom line, not only is the vehicle important, as you all know, the hardware and the software are key ingredients. So some of these companies are pure software play, and some of these are hardware play. And mostly, they all want to work with the mobility, or the Lyfts and the Ubers, because they see customers coming to them to use their car. Why else are companies banding together? It takes a bottom line. There's going to be a need for a lot of money to go autonomous. Folks, I can't spend a whole lot of time on it, but just to say the idea of scenarios and to be able to handle multiple scenarios is key to go from level 4 to level 5. Scenarios are, the kinds of things that happen in city driving or highway driving, and the ability of autonomous car to automatically handle it without involving the driver, or of course not getting into an accident. We'll say that.
And Chad, before you go on, you've mentioned level 4 and level 5 a couple times. Can you just describe just really quickly what you're talking about by those?
Yes. What I'll do actually, Dirk, is I have a slide explaining SAE, automation levels from level 0 all the way to level 5. So in about 10 slides or 5 slides, I'll cover that. Is that okay?
Awesome. Yep, that's perfect.
I'll just say this: level 0 is no automation. Level 5 is a completely automated car. Okay? And then there's gradients in between, and car companies and all of us measure vehicles in that fashion. Currently, most of our cars are level 2, many of them trying to go to level 3. Okay? All right.
Yep.
So some discussion points. What are the implications of the shift from electric vehicles to autonomous vehicles? Well, maybe after this, I'll give you a pause to ask questions. The big implications of the shift from ICE or internal combustion engine to EV and AV is that if you are purely supporting mechanical, even if it's mechatronic, and you're getting the hardware from somewhere else, you know, you need to pay attention to electric vehicles and autonomous vehicles and make sure your product has a place in the future, right? And what is the role of software and electronics? Software and electronics are key ingredients of the electric vehicle and the autonomous car. Why electric vehicle? Because we're talking about a connected car. That's why cybersecurity, you'll find out, is one of the 7 pillars. And, you know, in terms of, standards that we have to pay a lot of attention to. And with mobility as a service, there is a shift from the vehicle manufacturer, you know, having lots of control to the mobility as a service supplier having a lot of control. How about the supply chain? You know, we have very deep supply chains. As we worked with a large electronics company that was putting together an electronic platform for AV, autonomous vehicles. It's not just for AV. We'll just say this. They had 300 sites involved in making this hardware and software. Of course, that is a unique example. You know, I'll just say also this. I'm doing a lot of ASPICE and 26262 assessments, and what we're finding is that we're design teams on the U.S., Europe, India for software, China for hardware, testing even, you know, in India and Mexico. So we are very diversified. It's not, that's what I have to maybe say it's the importance of the design supply chain, including, of course, the manufacturing supply chain. But really, if I edited this, I'm trying to really focus on the design supply chain and the difficulty of doing design when everything has to link together, which you saw in my white paper. So what are the implications of EV and AV to product development? End of the day, there are 6 or 7 or 8 different things. I'll try to give it to you off the top of the head, which I detailed actually in the second revision of my white paper. But the idea of the structure or the systems, hardware, software, you know, system, subsystem, is the requirements flow down. It's the V model. And the importance of linking together requirements and the decomposition of requirements. Okay, I gave you a few there. This is the implication and the idea that, if you want to think of it, is the APQP phase 2 of the system supplier, the hardware supplier, the software supplier needs to be all lined up, and testing needs to be all lined up, because you have to integrate hardware and software first, hardware, software, and system next, and then you have to do hardware, software, and, you know, I mean, the whole system at the vehicle level. So testing has to happen in sequence and planned. Now, I already mentioned to you, partnerships and agreements, the reason is money. It's going to take a lot of money to become autonomous level 4 and 5. Again, I'll just mention this. We jokingly say it is now a gold rush. Everybody's rushing to come up with the autonomous vehicle because a little bit it's winner take all. That is, if you are the only autonomous player in the market, my gosh, you know, there's a lot of power there, and you will have a significant advantage. If you have a 3-year advantage, I think it's all over for somebody else. They'll become the GM of the future, like the GM of the past, if you know what I mean, where they will get anywhere from 60 to 70 to 80% of the market, you know, before anybody else comes in. So that there is the reason you want to be the top player. So what are the EV basics? Number one, this is a high voltage vehicle with high voltage battery, motor control unit, charger. You know, and remember the chargers outside. Chargers need to be all over, you know, everywhere so we can go charge it. And what does it bring in? It brings in its own considerations. It's got new technology, increased software and hardware, safety concerns, cybersecurity concerns, supply chain concerns. So what is it? Many different things that we didn't have before. You know, could the electric vehicle have unintended acceleration? Yes, unintended acceleration. Could it have a shock, because it's high voltage, you know, if you had a accident, you know, the chassis could get, you know, in touch with the high voltage system and somebody could be electrocuted. Or just by some, you know, bad design, you know, the battery could end up, you know, electrocuting the driver. Or combust, explosion, battery fire, and so on. Of course, you can still have brake failures. The big concern also is sudden deceleration. Is sudden deceleration such an issue? Yes. If you're going in the highway and you suddenly decelerate, you know, somebody could come and hit you, okay? It's what we call ASIL C or ASIL D event. All right. So there's the electric vehicle. So all the future vehicles will be electric vehicle and autonomous car on top of that. What's about the autonomous car? Lots of different cameras, sensors, radars, ultrasound. Why? Because they need a self-driving vehicle needs a perception system. Here it is, Dirk, the level 0 through level 5. Again, level 0 is no automation. Level 5 is full automation.
Perfect.
Great. You know, and level 1 has some driver assistance. Right now, we are seeing people trying to come up with level 3 cars. All right? Let me just tell you this. I'll explain level 3 and all these in a second, but let me talk a little bit about the difference between level 4 and level 5. Well, maybe I should go directly to this picture. This picture lays things out very clearly. Look at the, you know, 4 different columns here, and you can see, you know, steering. Who's doing the steering from level 0 to level 5? Who's, you know, whether the driver needs to pay attention and be seen. And when there's a problem, level 3 will go to the driver. So it's a drive mode specific performance by an automated driving system. And if there's a problem, it'll ask the driver to intervene. You could say the highway driving of the Cadillac with the Super Cruise is a level 3, okay? And the difference between level 4, you can see level 4 and level 5 looks the same, but you know, it's a sum and all. That's the big difference. That they call it operational ODDs, operational design domains, which means the level 4 vehicles are under very specific scope, meaning it's maybe inside just highway driving, or it could be just taking people, you know, around a route in a university, or it could be inside a mall. All that is level 4 if it's completely automated. And of course, soon as you go from some to all domains, that's the difference between level 4 and level 5. And I do believe level 4 will be reached. And, you know, level 5 will be a challenge. But I tell you, somebody's going to think of something, you know, in terms of going from level 4 to level 5. But, you know, when in the conferences I participate, we've had different people come in and talk about infinite number of scenarios. I mean, that's the world we're in. God made these infinite scenarios when we go from point A to point B. Children could come running out in the front. Adults could stroll, walk their dog and walk in front of your vehicle. The vehicle could look at a sign where it says stop and somebody has drawn something somewhere on the ground and it mistakes it for a stop sign and abruptly come to a stop, sending off the airbags. So airbags, airbags can injure people and so on. And of course, the danger of collision from behind. That's the challenge from going from level 4 to level 5. Look at the amount of automation, sensors, radars, cameras, 28 to 32 for level 5. And as you go further and further in terms of a car being able to see everything, can you imagine the amount of software we need? So people are using machine learning, AI, for capturing scenarios and telling the car what to do. And of course, there's an infinite number of scenarios. I guess what people are arguing is that as long as you get the autonomous car safe enough, and they say safe enough means that it's better than the current safety levels, then you can start going to level 5, even though the level 5 is not perfect. I could talk a little bit more about that in terms of what people are seeing. Remember I talked to you about safety. So you can see here 2012, we had active safety and drive assistance, in terms of blind spot detection, lane change assist, to lane centering, to 2018, adaptive cruise control, which you're seeing in the Super Cruise. And so they're saying commercialization of level 2 is where we are currently, 2019 to 2020. And then comes the Waymo, the Lyft, and the Uber, and the Apple with their vehicles, the commercial advent of disruptors, 2021. And they're seeing, level 4 coming in 22, 25. Really, I think the mobility as a service market will take, control soon as we commercialize level 4 for the highway, with the idea that the hours of driving the highway could be taken over by an automated car, and then you'll just need to be dropped off from your home as soon as you get out of the highway. Anyway, so this is the roadmap people are seeing, and maybe they'll be 5 years late, but it's happening. It's going to happen. But electric vehicles will happen sooner, and then followed by autonomous vehicles. All right. So what do we need to do? Because these products are getting designed today. Many of you may already be doing electric vehicles and autonomous vehicles and not knowing that you are. In fact, companies still are at the state where they're not even doing functional safety so well. Functional safety, or ISO 26262, I might as well go to the next slide. So ISO 26262, which came out in 2011, was updated in 2018. People are still getting their arms around that. People don't even realize that there are parts of the standard which are, integrated with the management system. And of course, that there is a part 4, 5, and 6, which is system, hardware, and software, how that needs to be integrated into the new product development process of the organization. I don't want to keep going on this here. The point I wanted to make is I just did an executive overview. Well, it's been a couple of months. And on 26262, for the president of this large, electronics supplier, and somewhere in the middle of it, I said something about ASIL and 26262. So suddenly he latched onto it and he said, "You mean ASILs mean 26262?" I said, "Yes." so-and-so. ASILs, if you have products with ASILs, it means you have to do ISO 26262. That ASILs are the starting point for the safety goals and safety requirements. I forget what I said. But 2 minutes later, he said, ASILs mean 26262? I said, yes, so-and-so. ASILs means 26262. Then he went a half hour later, and he said, ASILs mean 26262? I said, yes, ASILs means 26262. This is where companies are. They haven't realized that, and they thought they had 2 projects. By the time I gave the executive overview, they found out they had 14 projects worldwide that had functional safety. People have cybersecurity in the RFQ, and nobody knows there are cybersecurity standards that you need to be looking at. All right, so this is what we're calling the 7 pillars, starting with IATF 16949. As Dirk mentioned to you when he opened the presentation today, he read out to you that these other standards are going to affect and change IATF 16949. I talk about that in my article, in my white paper. So we have ISO 26262, functional safety. All of you should have heard about it by now. And then we have automotive SPICE, which actually gets pulled because of embedded software requirements from IATF 16949. And you'll say, well, it doesn't say automotive SPICE, but de facto you have to do either automotive SPICE or CMMI. And really, all the European OEMs are going SPICE. Ford is going automotive SPICE. This is what we recommend. And then let's just jump. We have SOTIF, we have cybersecurity, and agile APQP. So I don't spend a lot of time in this presentation talking about agile APQP, though it's near and dear to me. There's so many other things we need to do that, I don't have time to talk about. Of course, software companies need to figure out how to do agile and APQP and, functional safety part 6. But let me just say this. Agile APQP not only talks about software, but it's about agile at scale. For those of you who know what I'm talking about. All right. So let's touch on each of these, starting with IATF 16949.
Chad, quick question. So on that earlier slide, yeah, exactly. Are you saying that these other standards or requirements and so forth, 2 through 7, that if you're going to meet the requirements of 16949 and risk management and so forth, that you're probably going to have to be doing these other things as well just to meet what the future requirements might be of 16949?
Very good question. So if you're going to do electric vehicles and autonomous vehicles, these are the standards you're going to have to adopt. So not so much IATF 16949, Dirk. Since the whole premise of this presentation was safety products, electric vehicles and autonomous vehicles, we're saying that's the future of the industry, and the future of the industry is having a management system with these 7 different levers. Okay. Does that make sense?
Yeah, so you'd have to somehow incorporate all of these into your QMS if you're doing EVs or AVs in the future.
Right. So let me just, I'll just say it here in a thumbnail. 26262 is for safety, okay? ASIL levels coming out of HARA. Cybersecurity is there in every product. Well, let me not say that. You'll have to do a TARA, threat and risk analysis, and just like ASILs, you'll have CALs, okay? ASPICE is for any software. As soon as you put ASPICE in place, you have system requirements and software requirements. So the system, all the requirements of the system will have to follow ASPICE and so on. But I'm going to talk about this, and let this be the first introduction for those of you who may not know, as much about the standard. There's a lot I need to say, but if I in terms of clarifying things for you and things like that. But I'm going to be very precise and correct. And I know you might end up with some misunderstandings, but we'll continue talking about this in greater detail as we go on. So here we have the IATF 16949, which started out as QS 9000. The standard keeps getting evolving, and the standard needs to evolve and change in those 7 or 8 different ways I mentioned, from change management, which I didn't mention, to supply chain, to product design requirements. Even requirements management needs to change. The V model needs to come in. Several new changes need to come in, not only the IATF 16949, but the APQP and the PPAP needs to change. The FMEA has already changed the AIGVDA, and we'll mention the AIGVDA is a methodology that really supports the system structure. In systems engineering, the system hardware software evolution in terms of design. Keep that in mind when you do AIGVDA and any of these other standards. You have to change the way you do design, and you have to structure your design. All right, let's go on. I'll just mention also the PPAP. It's very old. It was formulated before 1995, actually. Okay, and the Ford's ISIR became PA, the production part approval process, and it is really there for mechanical products, and it needs to change. If you looked at my paper, this is the phase gate new product development process. Most of these standards I'm talking about is focused on phase 2, product design. Okay, so suddenly the product design and APQP, 8.3 in IATF 16949 needs to change quite a bit. So this, folks, can be done with the 4th edition, or it can be done with the AIGVDA. But bottom line, there needs to be, requirements decomposition. And the requirements need to be defined as functions and requirements, and the DFMEA needs to link with the DVPNR. If you want to have, if you want to implement these, you need to have this V model, and this is a good way to implement the V model. All right. I have been giving, maybe I've given 3 presentations like this already, Dirk. I am not sure. I'm giving gold here, diamonds. and I'm not sure my audience is really understanding the importance of what I have to share with them. And this is one of those very important slides in terms of understanding. People are struggling right now how to do the V model. Of course, you need software, and every software package out there does not meet these requirements. So this is something I saw and Omnex saw a couple of years ago. So, of course, Omnex's Aqua Pro meets these requirements and helps you meet this requirements decomposition and the V, engineering V, that's absolutely important. So we have about 15 minutes, and we'll take a few questions. But let me walk through these standards. First, Automotive SPICE. What is it? It's a framework for, focused on software, but it starts with the system, because the software requirements have to be linked to the system requirements. Folks, this means, like functional safety is only a subset of the requirements that are linked to a safety goal. In ASPICE, it's all the requirements. It needs to be decomposed into the architectural requirements, and from there, the software requirements, SWE1 process, needs to link atomically to each of the system design, and then the architectural design and the detailed design. What am I finding when I do my audits and assessments? There are companies doing software design right from SIS2, meaning from requirements. All they have is system requirements, and they're doing the unit design from there. So you have not only these requirements, on the right-hand side, you have the testing that takes place from unit verification that the programmer does in software into integration testing, hardware and software, qualification and system integration, and blah, blah, blah. But the bottom line, if you don't have this requirements decomposition at every level, you cannot have testing at every level. You understand? And so the V model requirements are very important. Here is that V that I showed you shows up like this in the ASPICE standard. You can see, the ones in red are what's called a HIS scope, and which are predominantly what the OEMs are asking for is what is called a HIS scope, used to be called the VDA scope. 16 processes out of the 26 processes need to meet a maturity level of at least 2, and they would prefer you work your way into a maturity level 3, which means the whole organization is working like that, not just the projects. Okay? So, ASPICE. Next, of course, 26262. All of us know a little bit more about 26262 today. As I mentioned, it's the oldest of the standards. ASPICE was also there for quite a bit, but we in the automotive industry in the USA didn't look at ASPICE all that much till the IATF 16949 required embedded software inside the organization and suppliers adopt a process, a maturity level process like SPICE or CMMI. That is when we realized very quickly ASPICE was the way to go. And so here's 26262, focused on product safety and focused on just electrical and electronics and software in the organization. What's the issue? You saw the roadmap. With all this technological complexity, there are an increased number of systematic and random failures coming in. And so you need to have a methodology that really takes care of, ensuring safety in the product. And I'm not going to go through all of this, but I'll tell you the most important thing. A couple of things. Number one, Part 2 and Part 8 integrate with your business management systems. You can think of it as IATF 16949. It adds additional shells to IATF 16949. Part 4, 5, and 6 add to new product development processes at the system level, hardware level, and software level. Number one, you need to realize you need systems engineers. Everything starts with the systems engineers. We're finding lack of this understanding in Tier 1s as we work with them. Then what can we say? That the concept phase is typically a missed phase, and that has to start maybe even before the sale, when you're, right in the very beginning as you think of your new product. The first one of the iterations of the new product, you need to have a concept phase, and then you can just do impact analysis in subsequent, generations of that same product. If you have never done 26262, you need to do concept phase, of course, as part of the first phase. Let me just say this, design reuse, or the idea of having, once you do this, you can use pretty much all of it, most of it, for the next iteration. And those are points I want to make. Just also say that part, 2018, the second edition of 26262, now has opened it up to the truck industry. It's got motorcycle industry, and also has guidance for semiconductors who have embraced it in a big way. So why should semiconductor adopt this and all these 7 levers? Only because you saw how many, sensors, cameras, radars, lidars, autonomous car is going to take in, and how much more electronics is in a new car. So many new entrants coming in. somebody who was in the LiDAR industry told me there's 36 new LiDAR companies. Then we have something called SATF. So 26262 designs the product to meet the functionality, but at times there is functional insufficiencies and misuse. Let me give you an example of a functional insufficiency. 2 weeks ago, I just bought a brand new car from is the top of the line of a very large OEM. So I expected everything to work wonderfully. So I've got this habit of putting my key in my briefcase. So I came to this car. It had a kick sensor. So I'm using this example, a kick sensor, because it's such a small system or subsystem of a vehicle. So I went and did a kick sensor. I've seen that in commercials. And the trunk opens, and it sends the key because I was close enough. I put the bag in, kicked it again, it closed, and I go to open the door won't open. Why? My key is in the trunk. So I go back and try kicking it, it won't open. I tried everything. I didn't even know where the manual thing was, and I won't tell you how I saved myself. But you understand that everything worked, but they hadn't thought through the scenario of somebody leaving that bag and closing the trunk. By the way, my older car worked fine when I did that. So it's something that the designers didn't contemplate when they came up with the kick sensor. So it's functional insufficiencies of the day-to-day use of whatever function it is, and or misuse. So somebody could purposely misuse your product, and you have to think that through. And 21448 SATF helps you do that. Why especially I wanted to tell you what a kick sensor is, there's this idea that SATF is only for OEMs. And indeed, that's what all the scenarios that we're talking about, SATF is all about level 4 and level 5, but of course, every system provider has SATF to contemplate, but they don't know it. So the whole idea of the scenario is a sequence of several scenes, they call, of something, a trigger that triggers the scenario. And so here's a triggering event, a specific condition of driving a scenario. Example, while operating on a highway, a vehicle's AEB system misidentifies a road sign, and as a lead vehicle results in, it dramatically brakes, and of course the collision that happens because of this triggering event and this scenario of misidentifying road sign. Okay, so that's a specific scenario the car needs to take into consideration, just like the kick sensor had to take into the idea that the key might be in the trunk in the car. All right, next we have cybersecurity. So this is where we are today. We want our vehicles to be very connected. So here you see that we have music streaming, news, navigation on the left-hand side. On the right-hand side, we want to be connected, if we're in trouble, to a call center. Many OEMs have that. With the press of a button, somebody will come and help you. Could be a dealership in the back end. So connected is a cellular tower because for the phone, the smartphone inside the car. We have internet, cloud. In the bottom here is the future of vehicle-to-vehicle communications. By the way, there's a whole protocol for that. People are already designing vehicles with that protocol in mind. And then that V2V, communicating with your road signs and buildings and such, which they call the smart city and so on. All right? So a very connected car and a kind of very connected future for all of us. What does this lead to? Well, we have the threat landscape with organized and well-financed attackers. It could be countries trying to attack in. Individual hackers, amateurs, or people inside the company with knowledge who can come in and look at the threat characteristic. What is the motivation, fame, financial gain, hacktivism? All right, folks, you may or may not know, and this is ISO 27001, by the way, IT security. There's many organizations today are getting, attacked by hackers who are demanding money. So I said it as a joke, but our cybersecurity expert said, hey, it's not no joke. Somebody could hold you up, out of your $35,000 or $40,000 car and ask you for $500 or $1,000, I don't know. And that's 21434, which is a cybersecurity standard. That's also SAE J3061, which is not a bad standard at all. And just to mention to you, the 21434, which is right now in a CD draft, which is a change draft, committee draft, we expect it to come out end of next year. But folks, you need to already start. There are, we have classes already for cybersecurity, SAE J3061, ISO 21434. These principles can be applied today. So we have the TARA coming up with the cybersecurity concept, just like in functional safety concept, and where you identify CALs and you come up with your cybersecurity requirements. And both your functional safety requirements and cybersecurity requirements update system requirements. A cybersecurity requirement or a threat, hazard, could be a safety hazard also, by the way. But they all don't need to be safety hazards. But in the end of the day, you have system requirements, which are functional safety requirements and cybersecurity requirements, which then you have to design into your vehicle, into your system, into your hardware, and your software. So as we mentioned to you, it's still under development, and it is similar in compliance to ISO 26262. All right. With that, folks, let me give you 1 or 2 minutes to write down any questions you may have. I do know I went quite fast through that last bit. This webinar is being taped. You can go back and listen to it. I did, whatever I said was very, very accurate. And I did mention a lot about each standard, okay? So let me pause here, giving you a chance to write down questions you may have. All right, let me move right into the summary here. There's a product change from gas and diesel to electric and autonomous vehicles. So that's an important takeaway, for trucks, buses. And in some countries we visit, like India and China, which has the two-wheeler industry, motorcycles, or even mopeds, big changes. OEMs and Tier 1s need to develop strategies on coping with this change. The product shift and level 4 and level 5 automation will give rise to this mobility as a service market. Organizations will need to shift to electric vehicle and then autonomous vehicles. These are the same 7 standards for electric vehicle and autonomous vehicles. We do see that as these changes come about, we'll be adding more standards. EV and AV companies will need to adopt systems engineering strategy. And what we mean by that is, of course, the idea of structure, hardware, system, hardware, software. It's not just system. Sometimes you may have system which is a subsystem. The subsystem may have its own hardware and software, and the system may have its own hardware and software, right? So it's quite complicated. And and we do see a great big need for a software tool that ties all of this together, integrates new product development with these 7 pillars and the supply chain. This is one of the pillars. And just to tell you, Omnex is working on that. We think that's very important to have an integrated solution that integrates APQP and ISO 26262, requirements flow down, and the V model. And as these standards, come out, we'll be integrating cybersecurity by the middle of next year and so on. And because it's going to be an important need to be able to accomplish all this, you're going to need a software tool. OEMs and suppliers who who take on a design, but need to also adopt a design. So this is the design and process reuse strategy. The idea that that we do families of products, both at the vehicle level, the system level, the hardware and software, is an important realization on the design side. And to understand we manufacture things quite similarly on the process side needs to, move us forward in a reuse strategy that will, really lower our costs and improve our overall quality. So that is the webinar today, folks. Just to remind you, Omnex does both audits, implementations, and training. Here's some of the training we do in IATF. I think we're well known for IATF 16949. We also have Automotive SPICE, where we're doing our first INTAX, which means if you want to be an INTAX auditor for ASPICE, which is like third party, we have one in November, and we'll be offering it a couple of times next year also. But we also offer internal auditor training for ASPICE. We have SOTIF training, Agile training, 26262 training. You can see we have a lot of different types of classes and lots of cybersecurity courses. Over 30-some courses we have added on as our product shift towards the future. And we also have some general training, so it could be first baseline training for employees and management into this new area of autonomous and electrical, and also systems engineering. So we also have software and functional safety and APQP integrated software. With that,
sure,
Dirk, we can
take some questions.
A couple of questions. Yeah.
Sure. All right. So a couple minutes ago, you mentioned an integrated solution, and somebody wants to know when will that be available, and will you be able to demo it?
Yes. So we have 12 modules of an integrated solution today, which integrates everything from document management to audits to APQP, PPAP, safety plans, you name it. So right now, we have a completely integrated solution to which we have integrated in functional safety. And so in terms of our integration, that's what you can see is a functional safety APQP integrated solution and IATF 16949. Of course, we also integrate in, ISO 14001, ISO 45001, or if you're a company with multiple QMS standards, we help to integrate all of that. Sorry for a long answer, Dirk.
Okay. Which OEMs are requiring the AIAG VDA FMEA?
So the AIAG VDA FMEA, we will learn more. In fact, this week there's a quality summit. Right now, as we speak, I don't expect it to be a mandated solution. It is a solution for folks who want to have a common, a lot of our tier ones and OEMs have both the European presence and a North American presence, and there are competing standards. So anybody who wants to not have one and have one standard inside the company should implement AIGVDA. Number two, it is a good standard to integrate with a few caveats. And I'm not going to repeat what they are. You can use AIGVDA. You could also use the 4th edition, but you could adopt that and get the V model. That would be the second most important reason why you want to do that. So, in summary, nobody that I know of that has made that a requirement. We do know who OEMs will accept that, and then it's a self-determination because of the advantages the AIGVDA holds.
Okay. As you were going through this, Chad, it occurred to me that if you're a big automaker or a big tier 1 supplier or something like this, that you can just throw resources at this because you've got the resources. But how is this going to impact the smaller suppliers that maybe incorporate software into their subsystems, or maybe they're buying a subsystem that has software into it and incorporated? I mean, are these people all going to have to be now overnight software experts in order to meet the requirements of some of these standards?
Pretty much this is the way the industry has gone. I'm sure there'll be some products which is purely stay mechanical, but I can't see many, even in the outside chassis. That's where all the sensors and the radars and the cameras and everything else get embedded in, and it's a different world. And even just 20 years ago, or I don't forget exactly when I was very close to OEM as they were reducing the supply base. They made a very conscious decision that the tier 1s are very large suppliers. But let me just say this: the OEMs now are looking for innovation, and the market is wide open for this innovative, smaller company that can come in and give them a solution. But these solutions are going to be, in my opinion, Dirk, hardware and software solutions, AI, sensors, and so on.
So, early on you mentioned all the various, safety issues, functional safety and so forth, and even just safety for the manufacturer itself when you're dealing with high voltage and stuff. So is any of this going to affect safety standards like OSAS, that sort of thing?
So really, OSHA's or ISO 45001 is about the occupational hazard inside the organization. There is a danger, in the assembly of a battery that there is electrocution possibility in the very end of the line. But these standards are a little bit different in that this is about designing safety into a product. Whereas ISO 45001 is much more about inside the, what are the hazards inside, can I fall and, hurt myself? Am I going to breathe noxious fumes? Though noxious fumes is one of the safety goals in a battery management system. Okay. Well, I think we're, we ran over a bit. That was great. We had some good questions there, and also a lot of really, really good information. So I think that's it. We don't have any more questions waiting, so I think this is probably a good point to stop. So Chad, thanks a lot. Really, really good stuff. As Chad mentioned, a recording and the slides will be available. This was really jam-packed. Chad did cover a lot of info, so you will be able to go back and watch that recording and look at the slides at your leisure, and that will be supplied to you by Omnex. And typically, you guys, Chad, I believe you send these out usually within a day, that information. So
you should be looking for that sometime tomorrow, I would assume.
I'll just Dirk, I think we take a little bit longer than that, but folks, we do send it out. And
there you go.
Please let us know if you'd like to see the slides or the recording.
Perfect. All right. Well, thanks to all of you for joining us. Chad, thanks once again. So from all of us, from all of us here at Quality Digest and Omnex, have a great day, and we will see you at the next webinar. So long.
Thank you, everyone. Bye-bye, Dirk.
Bye-bye, Chad.